Hello friends, the question is, a compound of formula A2B3 forms HCP lattice. Which atom forms the HCP lattice and what fraction of tetrahedral void is occupied by the other atom? So basically, we have to find from either from A to B which of the following forms the HCP lattice and which occupies the tetrahedral void. Let us assume B forms HCP lattice and the total number of atom be n. Since we know that it is going to be 6 for HCP lattice, but let us assume it n for option check. And going for option 1, since B form the HCP lattice, so the total number of tetrahedral void is going to be 2n. Checking option 1, since it is given HCP lattice formed by B and 2/3 of the tetrahedral void is occupied by A. So 2/3 of 2n is occupied by A, which is equals to 4n by 3. So the formula according to option 1 is going to be A and B n, which is equals to A4 B3, which is not matching with the formula given in the question. So option 1 is wrong. Going for option 2, let A form the HCP lattice. So according to option 2, A forms let HCP, which is n. So B is going to occupy the tetrahedral void position, which is 2 by 3 of 2n, which is going to occupied by B. So the formula is AN B 4n by 3, which is A3 B4. It is also wrong as the formula in the question is A2 B3. So this is also wrong. Looking for option 3. Again, A forms HCP lattice according to option 3, and 1 by 3 of the total tetrahedral void is occupied by B. So the formula is AN B 2n by 3, which is A3 B2. This is also not matching with the question, that is A2 B3, so it is also wrong. Now again checking for option 4. B forms lattice and 1/3 of total tetrahedral void is occupied by A. So the formula is A B n, which is A2 B3. Hence option 4 matches with the formula, that is A2 B3. So the correct option is option 4. Thank you.
The question is, at 100 degrees, copper has HCC unit cell structure with edge length of X angstrom. What is the approximate density of copper in gram per centimeter cube at this temperature? And the atomic mass of copper, it is given, and these are the options. So the density of the solid, it is given as Z into M, upon Na into AQ, where this Z is the number of atoms in one unit cell, M is the molar mass of the solid, Na is the Avogadro number, and AQ is the volume of the unit cell, and A is the edge length. So for calculating the value of this Z, we know that this copper, it has FCC unit cell structure. So for FCC, the atoms, they are present at 8 corners and 6 face centers of the cube. So it will be equal to 8 into 1 by 8. This 1 by 8 is the contribution of the atom at the corner per unit cell, plus 6 into 1 by 2. This 1 by 2 is the contribution of the atom at the face center per unit cell. So from here, the value of Z will be 1 plus 3, it will be 4. So 4 atoms, they are present in one unit cell for FCC. So now if we put the values in this formula, so we have to calculate the density. So density will be equal to Z, which we have calculated, 4 into M, which is molar mass, and it is given 63.55 U, or it is 63.55 gram per mole, divided by Avogadro number, which is 6.022 into 10 raised to the power 23 mole inverse into A cube, and this A is the edge length, which is given x angstrom. So if we convert it in centimeters, so it will be x into 10 raised to the power minus 8 centimeters. As we know that 1 angstrom is equals to 10 raised to the power minus 10 meters, or 10 raised to the power minus 8 centimeters. So now from here, if we solve, so we'll get density is equals to 4 into 63.55 gram per mole divided by 6.022 into 10 raised to the power 23 mole inverse into x cube into 10 raised to the power minus 24. We'll multiply this centimeter cube. So from here, this mole inverse will get cancelled out, and we'll get the density in gram per centimeter cube. So if we solve this, we'll get density is equals to 422.1 divided by this x cube gram per centimeter cube. So our correct option will be option 2.
Hello students, the question given is which type of defect has presence of cations in the interstitial sites? Okay, so let's see. Suppose we have a crystal NaCl. Okay, we have sodium chloride crystal. Now in NaCl, what we have in NaCl, we have two different ions, Na plus and Cl minus. Suppose here we have Na plus and here Cl minus, Na plus and Cl minus, and here we have Cl minus, Na plus and Cl minus. Now here cation is vacant, okay, and here now we have again what, Na plus and here Cl minus, and here Na plus and here Cl minus. Now the missing cation will occupy the space in interstitial site. Okay, there is a missing of cation. Which cation? Na plus. So here cation is missing. It should, what we should here Na plus. Na plus should be here, but now Na plus is vacant and occupy the another position is called interstitial position. So here it will occupy the interstitial sites. Okay, so the defect in which our cation is missing from the lattice site. Okay, this is its lattice site and occupy the interstitial site. Interstitial site is this site, and these all are interstitial sites. Okay, if cation occupy the interstitial sites, then the defect is called Frankel defect. Okay, this is called Frankel defect. Frankel defect. So this is our Frankel defect, because in this defect cation is occupy the interstitial sites. If both cation and anion are missing, then the defect is called Schottky defect. But here only cation is missing and occupy the interstitial sites, so that's why we call it a Frankel defect. Okay, this will be our Frankel defect, and it is clearly mentioned in NCERT. Okay, this is simple theory based question. This defect is called Frankel defect. So which option is correct? Option A. Option B is wrong. Option C is also wrong. D is also incorrect. Only correct option is option number A. Frankel defect is correct answer. Thanks.